Hello students, welcome to Modern Group of Education Kolkata. So today we are going to start a new chapter that is known as oscillation. Oscillation, it is also known as SHM in your class 11 syllabus. Oscillation and wave are the most important chapter of class 11 because it carries a more weightage than the other chapters, and it will also help you to build the concept of AC and wave optics of class 12 syllabus. Okay, so you have to know the oscillation chapter and wave chapter uh, clearly. Okay, so now starting the chapter oscillation. First of all, in this chapter you have to know what is known as periodic motion. What do you mean by periodic motion? Periodic motion means a period. That means a motion which repeats its path after some time interval. A motion which repeats its path after some time interval, just like a circular motion. A circular motion, in a circular motion, a body repeats its path after some time interval. This is a example of periodic motion. Okay. That doesn't mean that only the circular motion is a periodic motion. Any motion which repeats its path after some time interval is a periodic motion. Just like us. That means we are the human. We repeat our path. We repeat our schedule after some time interval. Okay. So we follow a periodic motion. Clear? So if a man does not have a schedule or a period, that doesn't mean he will get success in his life. Okay. So periodic motion is a motion which repeats its path after some time interval. Clear? Achha. Now what is oscillation? Oscillation is it is also a periodic motion. Oscillation is also a periodic motion, but the method of repeating its path is not the same of periodic motion. It is known as to and fro motion. That means it will cross the at every motion it will process its mean position every time. Okay, that means this is the mean position. Okay, so it will start from here and again it will go to there. That means it will cross the mean position every time. Okay, so this is called to and fro motion, here and there. Okay, this is oscillation. Now what is SHM? SHM means simple harmonic motion. Though the name is simple, but it is not simple as well, but it is a simple harmonic motion. So what is simple harmonic motion? It is a type of oscillation, it is a type of periodic motion, but there is some condition with that. So you can say that in SHM the two conditions are to follow SHM. One is the force will be the restoring force. Okay, I will tell you about the restoring force in later, but now you have to understand that restoring force is proportional to negative of the displacement. Okay, x or y. We can write x or we can write y. So SHM is a force motion where restoring force is proportional to negative of the displacement, and another acceleration is equal to omega square into x or y, where omega is the angular frequency. I will tell you about these points later. Okay, so first of all you have to know all the conditions of SHM. In SHM the restoring force will be proportional to the negative of displacement and the acceleration will be omega square into displacement. Okay, clear? Now thing is that you can say that the oscillation all oscillations are periodic motions. All oscillations are periodic motions. All oscillations are periodic motion, but all periodic motions are not oscillation, because periodic motions, oscillation is a type of periodic motion, but in periodic motion the body will repeat its path after some time interval. It do not cross the mean position every time. Okay, all oscillations are periodic motion, but all periodic motions are not oscillations. Clear? So you have understood the periodic motion, oscillation and SHM, the condition of SHM. Now coming to the point that the restoring force. Okay, now coming to restoring force. So what is restoring force? See, in a SHM, just like a pendulum, the pendulum, if we displace the pendulum here, then the pendulum will repeat its path just like that. Now the question is that the in which force, by the help of which force it will repeats its path. Okay, by which force it the body, the bob, this is known as bob, the body repeats its path. This is known as restoring force. Restoring force is a force which will help a body to regain, you can say it will help to maintain its position, initial position. Okay, so restoring force always acts towards the center, always acts towards the mean position. It is always acting towards the acting towards mean position. Okay, later you will know about the mean position, but you have to know now that the restoring force always acts towards the mean position, and it will always uh, it is proportional to the negative of the displacement, because the body is going to this and the restoring force is acting in this direction. Okay, this is the direction of displacement, this is the direction of displacement, and this is the direction of restoring force in this hub. And again, if the body is in this hub, then the displacement is this direction and the restoring force is this direction. Okay, clear? So the only one and only work of restoring force is to maintain the initial position of the body, to keep the body into the initial position. Okay, the starting position. Clear? Now some important terms you have to understand, some important terms. One is mean position. First of all, it is the mean position. There are a lot of myths about mean position. Some people say that mean position is the starting position of a body, or another some people say that the mean position is the middle point of the motion. It is actually not. Mean position is that position where the net restoring force, net force acting on the body, net force is equal to 0. That means F net is equal to 0. That means the force are acting, but the effect of the forces are equal to 0. So F net equal to 0. The mean position is that point where net force acting on the particle is equal to 0. That is called mean position. Okay. It is not the middle point. It is not the starting point. A body can start from anywhere. If say this is the mean position, the body can start from this point also, this point also, this point also. Body can start from anywhere to complete a SHM. But mean position is that position where the net force acting on the particle is 0. Okay, in most of the cases, in 80% or 90% cases, most of the cases the mean position is at the middle point, but you cannot say that the mean position is only the middle point. It is the net force acting particle 0. It is the point where the force acting on the net force acting on the particle equal to 0. Clear? Now second thing is that it is known as time period, or other, or else you can first you can understand about amplitude. Okay, what do you mean by amplitude? Amplitude is the maximum displacement or distance covered of a body from mean position, just like this. If a body is moving like this, then this line is known as the mean this line is known as the mean position line. This line is known as the mean position line. So the body covers this distance from the mean position. So this is the amplitude. Okay, the value of this is the amplitude, class A, and this is minus A. Clear? So this is the amplitude, the maximum distance or displacement covered from the mean position. Clear? So amplitude is a distance, and its unit is meter or centimeter, etc. The unit of length. Clear? Now at the third point, you have to know the time period. These are the basic terms you have to clear, because in total SHM, in many times this will repeat the time period, amplitude, etc., etc. Okay, so first of all you have to clear all the terms. Time period, that means time required to complete a oscillation. Time required to complete a oscillation, one single oscillation. Okay, so in this figure, if the body starts from here, the origin or the mean position, then this from here to here, this is the one time period. From here to here, this is the one time period. Okay, this is the one time period. Clear? It is a one oscillation, complete oscillation. So the time taken to complete a single oscillation is one time period. The time period, the unit of time period is second. Okay, now for frequency, the time period is noted as capital T, frequency is noted as F or nu. In CBSE, we denote the frequency as F. So frequency F, what is F? Frequency. Frequency is the number of oscillation in 1 second. That means in a second there can be more number of oscillations. So the number of oscillations in 1 second. Here the time is constant, 1 second. Okay, so just like AC, just like our AC current, the frequency of AC current is 50 hertz. AC is 50 hertz. That means the unit of hertz is AC, the unit of frequency is hertz. Hertz is the name of scientist. So 50 hertz means the number of oscillation in 1 second is 50. That means the wave or the SHM will complete 50 oscillations in 1 second. Clear? So this is the frequency, and the relation between frequency and time period is frequency is equal to 1 by time period. Clear? It is inversely proportional to time period. Frequency equal to 1 by time period. Clear? Okay. Now next term is wavelength. Wavelength. In the previous figure, if you can see that in the previous figure, the length of a wave is known as wavelength. Wavelength means the length of a wave. So a single wave, that means a single oscillation, a single total time period, the length of a time period. If a body covers this from this in a time period, then this distance is known as wavelength. This distance. Okay. This is a wavelength. It is represented as lambda, wavelength, length of a wave in a time period. So wavelength is represented as lambda. Lambda, the unit is meter or centimeter, etc. Clear? The length of a wave in a time period. Okay. So now all the terms are cleared, and another two terms are there. One is wave velocity. So it is the velocity of a wave. That means in meter per second, in centimeter per second, etc. Okay, velocity of a wave, nothing extra about this. And number 7, wave number. Wave number is the 1 by wavelength. It is represented as nu bar. So nu bar equal to 1 by Lambda 1 by wavelength is known as wave number. Clear? So I have completed all the terms, the 7 terms. You have to know all these things, important terms, and carry on the chapter. Clear? If you do not understand or if you have any problem, then please comment below, and I will surely answer the question. Clear? So these are the important terms. Now I am coming to some equations of a SHM. Equations of SHM. First of all, it is a displacement equation. Number one is a displacement equation. Y equal to A sine omega t, and another y is equal to A cos omega t, and third y equal to A sine omega t plus phi. What are the differences between all the displacement equation? Y means displacement, y or x. You can write y, you can write x. The same thing, y or x. A sin omega t, A cos omega t, A sin omega t plus phi, or A cos omega t plus phi. What are the differences between all these things? So you have to know clearly, because this chapter is all about the equations, okay, and all about omega, phi, etc. So you have to know all the things very clearly to understand this concept, this chapter, okay. So what is phi? What is omega? Omega is the angular frequency. First of all, omega is the angular frequency, okay. It is the angular frequency. Clear? The linear frequency is f and the angular frequency is omega. That means omega is equal to 2 pi f, or we can write 2 pi by t. Okay, 2 pi means in one complete oscillation the angle is 2 pi and it is 2 pi f. Okay, linear, and f is the linear oscillation, linear frequency, and omega is the angular frequency. So you have to multiply 2 pi with the linear frequency, then you will get omega angular frequency, and f is inversely proportional to t, that means 2 pi by t. This is a very important formula. Another important formula of omega is omega equal to root over k by m. Okay, omega equal to root over k by m. This formula is also important in these two chapters, SHM and wave. Omega equal to root over k by m, where k is known as spring constant. K is known as spring constant, and m is the mass of the spring. Okay, so we will know about this later, but now you have to focus on these four equations. What is y equal to a sin omega t, what is y equal to a cos omega t, and what is y equal to a sin omega t plus phi, and what is equal to a cos omega t plus phi. What are the differences between, this is t, what are the differences between these equations? Omega t plus phi. Clear? Now I am erasing this part, please note down. Y equal to a sin omega t. Here a is the amplitude, y is the displacement, and omega is the angular frequency, t is the time. So if a body starts from the mean position, then the equation will be a sin omega t. The equation will be a sin omega t, because sine graph starts from mean position, origin, but cos graph starts from maximum position. Okay, so if a body starts from any position except the mean position, then the equation will be a cos omega t. Okay, but you can say if a body starts from the maximum amplitude, then the equation will be a cos omega t, because sine and cos, it has some 90-degree, the difference between sine and cos is 90-degree phase. Okay, so now what is the phase? Okay, so what is the phase? Now let's see. Phase, I'm talking about the phase. Let's say this is a wave. Okay, and another wave starts from here. A wave starts from origin, another wave starts from here. Okay, so what is the difference between their phases? What is the phase difference? The phase difference is if this is 90°, if this is 90°, and if this is 0°, then the phase difference is 90 minus 0. That means phase is only the starting difference between the starting position. Okay, phase is only the difference between of two waves of their starting positions. Here it is 0°, here it is 90°. So phase difference is 90°. Okay, if a wave starts from here and if a wave starts from here, so what is the difference? Say it is 90° and it is 0°. So the difference is also 90°. Okay, difference is also 90°. It is also 90°, it is also 90°, but in the first wave carries a negative sign because its phase is negative and its the second phase is positive. Okay, you have to understood the previous diagram, the first diagram, because it will clear about all the concept of phase. A phase is the difference between the starting position of two waves with some angular value, 0°, 90°. Okay, and the distance is known as path difference. We will talking about the path difference and phase difference in later chapter in wave, but you have to know the phase difference and path difference. This is the path angle difference is phi is equal to 90. Okay, del phi, you can say del phi, that means phase difference, that is 90°. On the path difference is the distance between the two starting position. There is a formula of path difference and phase difference, that is phase difference is equal to 2 pi by lambda into path difference. Okay, del p, 2 pi by lambda into del p, phase difference 2 pi by lambda del p. We will talk about this topic later in later chapter, in web chapter. Okay, so I am raising this part so you have understood the phase. Now what is the difference between the equations? A sine y equal to a sine omega t, that means the wave starting from the wave or oscillation, the oscillation starts from the mean position, and cos omega t, the oscillation starts from the maximum position, maximum amplitude. Okay, now here omega t plus phi, that means this equation, this SHM or this oscillation starts from a initial phase difference. Okay, it will start from an initial phase difference phi. Clear? And cos omega t, that means it will also starts from an initial phase difference phi. Understood? So a sine, a cos, the difference are there. Okay, for the sake of simplicity, we will only use the sine omega t, not phi. Okay, we will use the sine omega t concept. Clear? So these are the equation of SHM. Now second is the equation of velocity. That means velocity means dy dt. The velocity, for the sake of simplicity, I am considering the sine equation only. Okay, so velocity dy dt will be a omega cos omega t. Why? Because the integration, the differentiation of sine, I am doing more clearly, that d dt of y means a sine omega t. Clear? Here a is the constant, it will, okay, it will coming out from the equation a is a constant, but now d dt of sine omega t. So sine omega t derivative differentiation is cos omega t with omega out from the equation. So a omega cos omega t. Okay, so this is the value of v, equation of v, a omega cos omega t. Now to compare with the displacement equation, we can write it is a omega, sorry, it is omega into a cos omega t, where sin square theta sin square omega t plus cos square theta equal to cos square omega t is equal to 1. So we can write a into root over of 1 minus sin square omega t. Clear? So by putting the value of a inside in the inside, so we get a square minus a square sin square omega t. So a square sin square omega t is y square. See, this is the y, so y square will be a square sin square omega t. Clear? So we can write omega into root over a square minus y square. So this is the value of plus minus value will be there, because if we have done the root function. So this is the formula of, sorry, so this is the formula of velocity, v equal to plus minus omega into root over a square minus omega square y square. Okay, so this is the derivation point of v equal to dy dt. This will not require in the derivation part will not require in the NEET purpose, joint purpose, JEE purpose, but in both purpose you have to understood all the things. So v equal to plus minus omega to root over a square minus y square is a formula of velocity. Okay, in the next page, so we have gotten the formula of y equal to a sin omega t and v is equal to a omega cos omega t and plus minus omega into root over a square minus y square. Now coming to the third equation, which is the equation of acceleration. It is dv dt. So dv dt of v means a omega cos omega t. So a will coming out from the equation. So a into a omega is coming out. A omega is the constant value. So ddt of cos omega t. So it is cos, the derivation of cos, differentiation of cos will be minus sin omega t. So it is here minus omega sin omega t. That means omega square sin omega t. Clear? So it is minus omega square into a sin omega t. That means a sin omega t is the y. So we can write omega square y. So it is equal to omega square y. That's why in the first session of this chapter, I have already told you that the in previous page, in the first session of this chapter, I have told you that the condition of SHM is a equal to omega square x. Actually it will be a equal to minus omega square x. Clear? A equal to minus omega square x. So these are the two condition of SHM. If a body completes the SHM by oscillating, if a body following SHM, then one of this formula, one of this equation have to follow by the body, this or this. Okay, so there will be a question like that, the body, the frequent the acceleration or the displacement equation of a body is like this. So find that the equation, or find that the body is not body is completing oscillation or not, completing SHM or not. So you have to find whether a equal to omega square x, or whether you have to find a distance equal to proportional to minus x. Then you can prove that the body is oscillating SHM. We will do the numerical in later part of this video. Okay, so coming to the next page, so this is acceleration, value of acceleration is equal to minus omega square y or x. Okay, you can write x or y, anything, but the x or y denotes the displacement formula, displacement. Okay, so these are the formulas. And now coming to the fourth formula, which is kinetic energy. So kinetic energy is equal to half mv square, and if we already know that v is equal to plus minus omega root over a square minus y square. So after squaring the v, we get half m omega square a square minus y square. Clear? And potential energy, excuse me, potential energy Here the potential energy formula is equal to half kx square, because the body is not climbing or not going up to any distance, that is each distance, so we cannot write mgh. Okay, so here the potential energy formula is half kx square, where k is known as spring constant, x is the displacement. So half k x, this means y, half k y square, that means half k into y means a square sine square omega t. Clear? Clear? So please carry the y equation. You do not have to consider the y value. So please half k y square, where k is, we already know that k is equal to omega equal to root over k by m. We already know that omega equal to root over k by em. So after squaring both sides, omega square equal to k by m. So k equal to m omega square. Now put this value in the here, half m omega square y square. Clear? Half m omega square y square. This is the value of potential energy. I'm erasing this part. So this is the value of potential energy, and total energy will be kinetic energy plus potential energy. So this is half m omega square minus y square plus half m omega square y square. Then now the total value will be half m omega square a square. So total energy is a constant value. You can say that half is the constant, mass of the body is also constant, omega angular frequency is also constant, and amplitude is also constant. So total energy is constant. That means it will follow energy conservation. It follows energy conservation. Okay, now we will coming to the graph of kinetic energy, potential energy, total energy in the next video. So if you understood the video, then please like and share the video, and please support us, so that we can provide you the maximum highest possible value of the highest possible quality video, highest possible education with a free concept. Okay, so please support us and subscribe our channel and share the video. Thank you.